How are you, my friends? This is basic math terms, part 37 of the Calculus 1. Just to remind you that part 30 was the start of the Calculus 1 terms. And for the algebra terms, you can see parts 1 to 18. For the pre-calculus terms, you can see parts 19 to 27. And statistics terms will be parts 28 and 29. So this part is 37 about antiderivatives and initial value problems in Calculus 1. So the words we will see: antiderivatives, anti-differentiation, indefinite integral, first integral formula, simple differential equations, initial value problems, rectilinear motion, and summation notation. Now, this is a little diagram here that will clarify the relation between the derivatives and antiderivatives, differentiation and anti-differentiation. If we have a function f, we can use differentiation to find the derivative f prime. Also, from the same function, we go to anti-differentiation or antiderivative capital F. So an antiderivative, the definition of the function small f, is a function capital F, such that the derivative of the capital F is equal the function f itself, wherever f is defined. So differentiation undoes the result of anti-differentiation. So they are opposite in the mechanism. Indefinite integral, the collection of all antiderivatives of the function f is called indefinite integral. So we can write them as integral f of x dx is equal capital F of x plus c, if and only if capital F prime of x is equal to small f of x. So indefinite integral, we have another way of calling that. It is the most general antiderivative. We have to put here plus c, which is a constant. The first integral formula will be integration of x to the power n dx is equal x to the power n plus 1 divided by n plus 1 plus c, where c is a constant and n cannot be minus 1. Simple example. If we need to find the antiderivative of x to the power 5, so we make the indefinite integral x to the power 5 dx. See, we add here n plus 1, so n is 5. So it will be x to the power 5 plus 1 over 5 plus 1 plus c, which is x to the power 6 over 6 plus c, or 1 over 6 x to the power 6 plus c. Now, if you find the derivative of all this yellow part, it will be x to the power 5, because the derivative of the constant is 0. Very simple differential equation. What is a differential equation? It is an equation that involves differentials or derivatives. It's like this one here. We have y prime is equal f of x, and we need y is the solution. So we're using anti-differentiation. Y will be the integral of the function f of x dx. Initial value problem. What is an initial value problem? Is a problem of solving differential equation. We have a differential equation subject to a specific initial condition, like y of x sub 0 is equal y sub 0. So there is a condition here we need to apply for this differential equation. Y prime is equal dy over dx. Now let's look at rectilinear motion, velocity, and acceleration. If a particle moves in rectilinear motion along a straight line, the x-axis, then the motion of the particle is described by position vector, which is x equals x of t. It will give here x coordinate at time t. Now the velocity, v of t, is the derivative of the position function dx over dt. And the acceleration, a of t, is the derivative of the velocity, which is dv over dt, or the second derivative of the position function, d squared x over dt squared. In the conclusion, we can say x of t will be the integral of v of t dt, and v of t will be the integration of the acceleration a of t d of t. Summation formulas, these formulas you can use everywhere in Calculus 1, in Calculus 2, and in many other courses. Just four simple, nice formula you can remember always. Summation of 1, I equals 1 to n. So if you add 1 plus 1 plus 1 plus 1 plus 1 n times, let's say 7 times or 10 times, it will be n. If we have summation of the I equals 1 to n. This is the second formula. It will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus n. It will be the formula n plus 1 over 2. So if you need to add the first 10 numbers, it will be 1 plus 2 plus 3 plus 4 plus 5 until 10. So it will be here 10 plus 1 over 2. Now this one, when you make summation of I squared, and the last one, summation of I cubed. So just look at the sequence here. Summation of 1, only 1 in each time, 1 plus 1 plus 1. Number 2 is summation of the I. I will be changing from 1 to n. So 1 plus 2 plus 3. Third one, 1 squared plus 2 squared plus 3 squared plus 4 squared until n squared. Number 4 will be I cubed, summation I equals 1 to n. So it will be 1 cubed plus 2 cubed plus 3 cubed until n cubed. So for the summation of I squared, it will be the formula n plus 1 product times 2n plus 1 in the bracket divided by 6. The summation of I cubed will be n squared, n plus 1 all squared divided by 4. So you can see these in some math courses. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.